Welcome back to math class and welcome to 11-2. Yesterday we talked about how to find the area of parallelograms and triangles, so today we're going to talk about how to find the areas of trapezoids, rhombi, and kites. Hopefully you guys remember what a trapezoid, a rhombus, or a kite are, but just in case we'll review as we go. A trapezoid, if you guys remember, it's going to look something like this. It's going to have two bases that are parallel, but they don't have to be the same length, right? So whereas in a parallelogram, they're parallel and the same length. The trapezoid, they can be different lengths. So to find the area of a trapezoid, we take 1/2 the height and we multiply that by the lengths of the bases added together. So suppose this trapezoid was, let's just say it's 10 units. This length is 10. Let's say this one is 5. And then its height is like a little bit bigger than, well, I'm not gonna drop there. Let's say its height is about, looks like about 6 because it's a little bit bigger than, a little bit taller than it is wide. Okay, suppose that's our measurements to find my area, and then take area equals 1/2 the height, which is 6, times our two bases added together. So 10 plus 5. So 1/2 of 6 equals 3, and 10 plus 5 is 15. So our area is going to be 3 times 15, which is 45. Pretty straightforward stuff. One thing to keep in mind as you go is that the height is not the length of these sides, of its non-parallel sides. It's not the length, it's the distance between its two parallel sides. So you're always looking for a number like this that's coming from one side to the other at right angles. If you can make sure to keep that straight and remember your formula, this will be a breeze. Okay, up next we have rhombi and kites. I'm going to do those together because they're actually pretty similar. A rhombus is going to look something like that. In a rhombus, all of its sides are equal. They're kind of like squares, but they don't have 90-degree angles. So they're parallelograms in which all of the sides are the same. And a kite, oh here I'll label this, rhombus. A kite is similar but different in that kites also only have two congruent sides, and it's the adjacent sides. So in a kite we have these two that are next to each other are congruent, and these two that are next to each other are congruent. In a rhombus, all four are congruent. Oh, let me label this. Kite. Rhombus, kite. Now the way that we find the area of both a rhombus and a kite is by taking 1/2 and multiplying that by both of its diagonals. The D right there stands for diagonal. If you guys remember what a diagonal is, it's going from one vertex across to its opposite vertex. So the diagonals of this rhombus are this line and this line. The diagonals of this kite go like this. There and there. So suppose I said that the diagonal of this rhombus here is let's give it 10, and then this one going this way, this dotted one, it's a little smaller, let's say it's 80, or not 88. Okay, so if this diagonal is 10 and this one is 8, we just take those numbers and we plug them into this formula. So to find the area of this rhombus, I go the area equals 1/2 times this diagonal times this diagonal. So 1/2 times 8 times 10. So half of 8 equals 4. 4 times 10 equals 40. And the area of this rhombus is 40. Kite, it'll be the same. Suppose its diagonal, suppose this diagonal here is 4 and its long one is 8. I'm still going to take my same formula, area equals 1/2 times its diagonal times its other diagonal. And I'm going to solve. A equals 1/2 times 4, which is 2, times 8, 2 times 8 is 16. So the area of that one was 40, the area of that one was 16, based on the measurements I gave. Again, just keep, with these, what you're paying attention for is that you're using the measurements of the diagonals and not the sides. Hopefully that doesn't get you tripped up. With a rhombus or a kite, you're using the measures of the diagonal. So from one point to its opposite vertex. Otherwise, I think you guys got this.